When we use the term omnidirectional as an omnidirectional antenna, in theory, an omnidirectional antenna would transmit in a perfect sphere. It would transmit the same in every direction, north, south, east, west, up, down, and so on, just like a sphere. Now, we would not get any gain at all. Remember, gain from an antenna comes by focusing all the energy in one direction, like a nozzle on a hose, or adjusting a flashlight, the head of a flashlight. So this whole idea here is what we call an isotropic radiator, and it doesn't exist. We have no antenna that creates an isotropic radiator, but it gives us a baseline by which we can now measure the amplification of the antennas as they actually occur. But in actuality, when we talk about an omnidirectional antenna, what we mean is one that transmits outward, like an apple here, or like a donut. So it does not transmit here up and down, but it does transmit out in a perfect circle all the way around, and so we get some gain. Now, we don't get as much gain as we would if we went one direction, but we do get gain in every direction. So this would be what we would call an omnidirectional antenna. A typical omnidirectional antenna is one called a dipole antenna, sometimes called a rubber ducky because it looks like a little ducktail here. And we don't use these, of course, in multi-story buildings very much, at least not on multiple floors, because as you can see here, the signal doesn't go up and down very well. It only goes out across the floor. So this might be in the middle of an office, so that everybody in the office could get a signal. They are best at moderate heights, not too high, not too low, and then the antenna in the access point, whether it's built in or whether it looks like this, should be vertical. Otherwise you get a problem with polarity. That is to say, one antenna is sending the signal on its side. Imagine if you turn this antenna and this thing was up and down like a tire, you wouldn't get the same signal coverage that you do here. And the direction of the waves are also not going in the same direction as this antenna is looking to receive them. And I'm not going to get into that polarity issue and what that looks like as far as waves, but they clash with each other, and it's difficult for them to communicate. So these are typically used in point-to-point communications. So you have an access point in the middle of a room and a whole bunch of users out in that room. Next is a semi-directional antenna, roughly the shape of a hemisphere. So a patch or a panel antenna looks something like this. You've seen these on the walls or on ceilings, and roughly a hemisphere. So in other words, if it's on the wall, it goes out into this room, but it doesn't try to go through the wall and into the next room. Or if it's on the ceiling, it's going to cover the room, but it's not going to try to push a signal upstairs and lose some of the power that it could have going in one direction. So these patch and panel antennas are excellent examples of these semi-directional antennas. Yagi antenna, as we used to see a lot for TV reception on top of roofs. You may still see one once in a while. Sometimes they're covered like this. And these are also semi-directional, although they tend to be a little bit more directional than these patch and panel antennas, but we would still consider them semi-directional. Sector antennas are also very common. You've seen these things on top of poles for cell phones, and the idea is that one of these each is kind of a patch or a panel antenna, and it covers like a slice of pie, right? And if you go all the way around, then you can get all the way around, get coverage in every direction, and still get good range because each one is more focused than a dipole antenna. And then the unidirectional antennas, you've seen these. They're both the grid antenna and the dish antenna are highly directional, and they're going to send a signal out in a very directional format like this, so you can get those nice point-to-point links. And then finally down here, the radome. The problem with these guys here is wind and weather, and the radome protects those. And these things are designed not to not to filter out the signal, but to filter out rain and wind. That's it for these antenna types, kind of a quick look at all three types. And next we're going to look at something called the frontal zone.